November 11th. Once again, the sky has forced astronomers to confront something they were not prepared for. As 3I Atlas keeps diving toward the sun through a chain of relentless encounters, it isn't chaos it leaves in its wake, but clues. For days now, reports have circulated of intense, almost violent exchanges between this interstellar visitor and our star. Yet every close pass peels back another layer of mystery instead of tearing the object apart. Rules we once treated as permanent begin to shake. And in that thin space between what we know and what might be possible, a new idea starts to form. Has nature quietly exposed a fresh law of physics, or are we looking at traces of something that was once deliberately built? From the cautious speculations of Avi Loeb to NASA's drawn-out silence, from the delayed release of crucial images from the Mars Reconnaissance Orbiter to mounting demands for honesty from the U.S. Congress, the saga of 3I Atlas has already broken free from the confines of pure science. It has turned into a kind of psychological mirror, reflecting how we handle the unknown, how we defend what we already believe, how tightly we grip familiar theories, and how deeply we fear what we cannot easily explain. And now we look to the newest datasets and official statements to understand what astronomers have actually uncovered in the past few days, as 3I Atlas, this wandering body from interstellar space, continues its dramatic, almost choreographed interaction with the sun. At first glance, 3I Atlas seemed unremarkable, a faint drifter from deep space looping around our star on a predictable course. Then, almost in an instant, everything about it changed. 3 days ago, as it swept through perihelion, ground, and space-based telescopes, recorded a transformation that nobody had penciled into their models. Its brightness surged to nearly 5 times its previous level. Yet the real shock wasn't in how bright it became, but in how it behaved. Instead of the single, neat tail we expect to see streaming away from the sun, the object began firing off multiple jets in different directions, weaving a tangled, three-dimensional pattern of light and motion. And now the most recent findings point to something even stranger. One of those jets, the most puzzling of all, appears to be aimed straight toward the sun. No ordinary comet should behave that way. Under classical physics, radiation from the star pushes gas and dust outward, sculpting tails that always point away from the light source. Watching a plume move toward the sun is like watching a waterfall reverse and pour upward into the sky. Yet there it was, a column of gas seemingly pushing against the very pressure that should have repelled it. At first, the data were brushed aside. Maybe someone had misread the angle, maybe scattering effects created a visual illusion. But as more observations rolled in, the oddity refused to vanish. Telescopes from Chile to Hawaii reported the same pattern. The jets were not chaotic bursts, they were steady. They repeated the same geometric arrangement over and over, measured, consistent, almost as if they were following instructions. Spectroscopic measurements only sharpened the mystery. The gas was flowing outward at around 150 meters per second, a speed far too low to stand up against the constant battering of the solar wind. Under normal circumstances, those jets should have been blown back, twisted, and stretched into diffuse threads. Instead, they held firm, like invisible pillars of force anchored to the comet's core. Every standard model failed to recreate this behavior. If solar heating alone were the cause, we would expect random flashes of activity, brief explosive outbursts, jagged flares that came and went. But 3I Atlas displayed continuity instead of chaos. The jets pulsed in regular intervals, synchronized with the object's slow 9-hour rotation, almost as though they were responding to some internal timing mechanism. To visualize this is to imagine a dark stone drifting in space, quietly breathing, thin streams of vapor exhaled in perfect rhythm with its spin. Beautiful to watch and deeply unsettling. Explanations began to multiply. Some researchers proposed that stratified layers of gas were trapped beneath the surface and were simply escaping through multiple fractures, venting out through cracks as the crust weakened. But that couldn't account for the stability and repetition. Others suggested that rotational effects were creating multiple hot spots. Perhaps the comet was spinning fast enough to expose various active regions one after another, yet its measured spin rate was far too gentle for that. The equations refused to cooperate, so the discussion moved towards something more speculative, though still couched in careful language. What if the venting wasn't random at all? What if the gas was being channeled through narrow internal passageways like nozzles, focusing the outflow into sharply defined jets? If that were true, 3I Atlas would be doing something no known natural body does, subtly modifying its own motion. Could a relic of ice and stone possess a built-in self-regulating system, something that behaved suspiciously like propulsion? The idea sounded outrageous, but it matched the observed data more closely than any other theory on the table. Simulations run at the European Southern Observatory compared two scenarios, one where gas escaped randomly across the surface and another where the emission was guided through structured pathways. The first model dissolved into noise in a matter of hours, unable to maintain the observed geometry of the jets. The second, the channeled flow scenario, recreated the same structured, repeating jet patterns seen in real images. The official conclusion was phrased with extreme care, an anomalous collimation consistent with localized venting or organized pathways. No one openly claimed that the object was designed, but almost no one could ignore the apparent symmetry either. Somewhere between blind chance and deliberate intent, the real explanation waits. If the jets turn out to be a purely natural effect, they hint at a completely new type of behavior in volatile materials, a way for ice and dust to self-organize and regulate how they release heat. If not, then we might be watching something unimaginably rare, an engineered system that has endured for billions of years and is now reactivating in the warmth of our sun. The shift from stillness to action was so sudden that it felt like someone had flipped a hidden switch. What had once appeared to be a dormant lump of rock became, in an instant, an active structure. From that point on, 3I Atlas stopped being just another comet. It turned into a live experiment, a cosmic puzzle about what matter can do when the rules we rely on begin to warp at the edges. Researchers began to choose their words more carefully when they spoke about it, and sometimes with a kind of quiet awe. It's as if the object remembered how to move, one astronomer wrote in his notes. Maybe it was not memory at all. Maybe it was simply reacting to heat and light according to a blueprint etched into its structure long before our solar system was even born. Whatever the deeper cause, that sudden change marked the opening chapter of a much larger mystery. It reminded us that even in systems we consider predictable, the universe preserves a few hidden tricks, folded into the dark, waiting for just the right angle of sunlight to expose them. For weeks after perihelion, 3I Atlas seemed to settle into silence again. No obvious jets, no glowing flares, only a faint glimmer of reflected sunlight gliding over what appeared to be a metallic sheen on its surface. Still, the instruments aimed at it did not look away. Around the globe, arrays kept listening: radio dishes, optical telescopes, infrared sensors, and for a while they heard nothing at all. Then on October 24th, the quiet finally ended. From the arid plateau of South Africa, the Meerkat radio telescope picked up an unexpected signal. A narrow, clean line at 1.65 GHz, followed by another at 1.667 GHz. Together, they formed the twin peaks of hydroxyl absorption, the unmistakable spectral signature of water vapor illuminated by sunlight. It was the first true voice 3I Atlas had ever offered us. Hydroxyl lines are nothing exotic in cometary studies. They are a standard way to confirm that ice is turning into gas. What disturbed astronomers was the timing. By then, the object had already swung past perihelion. Under normal thermal behavior, its peak heating should have passed and activity should have been declining. Instead, just when things should have been calming down, 3I Atlas spoke up. The question arrived with razor precision. Why then? If the object's behavior were driven strictly by sunlight, its outgassing should have been strongest days earlier when the radiation was most intense. Yet no signal had been detected at that time. The first clear activation came only after the object had begun moving away from the sun, as though some internal mechanism had waited for a particular configuration and only then unlocked. At first, scientists tried to file it under coincidence. A late-activating patch of ice, perhaps, finally warmed enough to sublimate. But the timing was too clean, too sharply defined, and it refused to blend neatly into ordinary thermal logic. Deep inside the object, buried ice may have fractured and released gas, but the signal did not resemble a wild outburst. The spectral lines were narrow, more like a controlled leak than a chaotic vent. For years, the idea of a comet regulating its own activity sounded like fiction, yet now the data hinted at balance, not disorder. Scientists at the Max Planck Institute proposed an insulated shell, a dense carbon-nickel crust that slowed heat. In their model, sunlight built pressure beneath the surface until a vent opened, creating a delayed pulse that matched the radio detection. But the event did not fade quickly. The hydroxyl lines stayed steady for 36 hours, as if the opening remained just wide enough to bleed off energy without tearing the structure apart. Others went further. If the timing and shape of the signal were too precise to be coincidence, perhaps sunlight acted as a trigger, not just a heater. They imagined 3I Atlas drifting in silence until a specific blend of radiation struck its surface. Somewhere inside, a buried structure resonated and produced one disciplined breath, a single pulse, then nothing. Observations confirmed the pattern before the voice fell quiet again. Official reports called it a transient event. Privately, many suspected the real clue lay in the silence that followed. The extra force on 3I Atlas was tiny but relentless, a faint non-gravitational acceleration acting over millions of kilometers. That whisper of thrust was enough to bend its orbit. Normally, such drift comes from sunlight heating one side of a comet more than the other, creating uneven gas jets that act like small thrusters. But Atlas didn't fit that pattern. Its visible jets were weak, nearly symmetrical and fading. If sublimation were driving the motion, the thrust direction should have shifted as the comet rotated. Instead, the acceleration vector stayed almost perfectly fixed in the plane of its orbit, as if the object had chosen a direction and held it. Researchers checked everything they could: thermal models, mass estimates, star catalogs. Every correction sharpened the numbers, but the anomaly remained. That left only two broad options. Either some unknown natural venting system was producing thrust from within, or something more exotic was steering the comet. The cautious explanation imagined a network of sealed cavities beneath the crust. Volatile material could build pressure and escape through microscopic vents too small to form a visible coma. Each puff would be gentle, but together they could create a steady push. On paper, the physics just about worked, but the precision did not. If random cracks and vents were responsible, the thrust should flicker and wobble. Instead, for 9 days in a row, the velocity increased along a clean, nearly straight line. The motion looked disciplined. That word made people uneasy. Discipline suggests control. Control hints at design. Quietly, some scientists began to mention Oumuamua again. In 2017, that first known interstellar visitor showed a similar, unexplained acceleration without visible outgassing. Back then, it was treated as coincidence. Now the same pattern seemed to be repeating. One idea was that both objects might share a hidden architecture, an internal structure that responds to sunlight not just as heat, but as a trigger. Thin metallic layers beneath the surface could, in theory, absorb radiation and re-emit it as directed motion, a sort of photon-regulated drive. That could be a natural process no one has seen before, or a very old technology blurred into the background of space. The field split. Some argued for new physics, others insisted on humility and more data. But everyone agreed on one point: gravity alone could not explain what they were seeing. As Avi Loeb put it, the acceleration was small, steady, and unexplained. Whatever its source, it showed that our understanding of how some objects move between stars is incomplete. Outside the equations, a different picture formed. Maybe this wasn't propulsion in any human sense, but a kind of material memory, atoms reacting to light after billions of years. Imagine an object forged in another star system, its minerals aligned in a magnetic field that disappeared long ago. Under our sun, those atoms wake up, interacting with radiation in a slightly uneven way and creating a slow drift that only looks like intent. To us, a rock moves where it shouldn't, so we give it will. In reality, it may simply be obeying laws we have not yet written down. By mid-November, the deviation stabilized. Atlas settled into a slightly altered orbit that would carry it past Mars and back toward the outer dark. The extra push stopped as abruptly as it had begun, like a long breath finally released. No one knew if the mechanism was finished or only dormant. If it was internal, it might wake again when the sun lights it from a different angle. If something else was guiding it, perhaps the correction was complete. Officially, the final bulletin sounded dry. A sustained non-gravitational acceleration had been observed, with an unknown cause. Unofficially, the result felt profound. A silent traveler had stepped slightly outside gravity's script and adjusted its own path, reminding scientists that even their best equations are still guesses. Then came another surprise. When 3I Atlas emerged from behind the sun, telescopes expected it to fade. Instead, high-resolution images showed a maze of jets moving with structure rather than chaos. At least 5 active outflows pointed in different directions, one along the orbit, one to the north, and one, astonishingly, pointing straight toward the sun. That sunward jet broke the standard rules of comet behavior. Solar radiation should push material away from the star, giving every comet a tail that points outward. Yet Atlas was throwing matter back toward the light, as if pushing against the pressure instead of fleeing it. Spectral maps confirmed the jet was real and stable for days, its brightness pulsing with the comet's slow rotation. Several natural explanations were proposed. Perhaps gas from the shaded side was funneled through deep fissures that just happened to aim sunward, but that didn't explain the jet's long-term stability. Another model involved electrostatic forces and charged particles sliding along curved magnetic field lines, but the required charge levels were far beyond anything measured. So scientists turned to internal structure again. If narrow channels inside the comet directed gas through hardened conduits beneath the crust, they could produce a narrow collimated stream capable of pushing partly against solar pressure. Similar focus plumes exist on icy moons with cryovolcanism. Even so, Atlas's pattern seemed too rhythmic and exact, as if the rock were engineering its own response using the logic of its minerals. As if that weren't enough, its color changed. Before perihelion, Atlas glowed with the dull red of a dust-rich comet. Afterward, it shifted within days to a deep metallic blue recorded by multiple instruments. In astronomy, red often indicates dust and organic carbon, while blue can signal very fine particles or glowing gas. But the sudden, strong blue didn't match normal expectations. One idea was that ultrafine grains smaller than a micron were scattering light, implying Atlas was shedding extremely fine dust, perhaps the remains of a vaporized crust. Another pointed to molecular emission. Cyanogen and diatomic carbon can glow blue-green when excited by sunlight, yet their spectral signatures were weak, almost absent. The comet had changed direction, changed behavior, and even changed color. while the most obvious explanations stayed just out of reach. A joint team from NASA's Infrared Telescope Facility and ESA's Rosetta Archive compared 3I Atlas's new blue sheen with known comet spectra and found something shocking. The reflectance pattern didn't match carbon dust at all, but nickel-rich silicates, minerals that scatter blue light when strongly heated. Nickel again, the same element already implicated in its strange density and earlier absorption lines. If that interpretation is right, the glow isn't gas. It's metal sunlight glinting off a nickel-bearing surface suddenly laid bare. That would mean that beneath its dusty coat, Atlas may hide a core of heavy elements rarely seen in comets, more like planetary interiors or even manufactured alloys. Quietly, the speculation spread. Was this really a lump of primitive ice or a shard of something far older, born in the heart of a shattered world or built for purposes long erased? No one wanted to say artificial, but the word hung at the edge of every discussion. Officially, the language stayed cautious, a color change consistent with thermal alteration or exposure of reflective subsurface material. Unofficially, the rhythm in its light curve, brightness rising and falling with rotation, blue highlights flashing with each spin felt disturbingly organized. Atlas showed facets, moods, almost personality. How could something so small and ancient behave with such tidy order? One astronomer scribbled in his notes, "It's not resisting the sun, it's remembering it." Maybe the sunward jet and metallic blue were the echo of an origin where heat and pressure once sculpted its body very differently. Or maybe this was just another example of nature expressing precision without intention. Either way, that cold blue traveler reminded us that even simple laws of light can bend toward mystery. While telescopes probed its surface, another puzzle grew closer to home: silence. With a comet this unusual, the scientific community expected a flood of open data. Instead, updates came in fragments, summaries, partial tables, missing imagery. The official excuses sounded routine: calibration, compression, cross-checks, but the delays piled up. Physicist Michio Kaku finally voiced what many were whispering. In an interview, he accused NASA of needless secrecy. If Atlas was just a comet, why hold back the pictures? And if it wasn't, why pretend nothing was unusual? His calm challenge hit a nerve. For decades, comet missions from Hale-Bopp to 67P had posted images and spectra within days. But high-resolution shots of Atlas taken by the Mars Reconnaissance Orbiter on October 2nd and 3rd were held for over 3 weeks, and then released quietly, cropped and heavily compressed. Rumors filled the gaps. Some insiders described raw frames with sharp contrasts and oddly faceted shadows, features that looked more architectural than natural. Others dismissed it as saturation and image artifacts. At the same time, Congresswoman Ana Paulina Luna formally demanded disclosure of all Mars-based imagery tied to Atlas and even requested telemetry from the Perseverance rover, which had registered unusual upper atmosphere activity on October 5th. Officially, the rover wasn't studying Atlas at all. Unofficially, it was pointed in exactly the right direction to catch its light. Leaked internal memos spoke of imagery requiring contextual analysis before release, a phrase that explained nothing and implied too much. Blurry, high-contrast copies began circulating anonymously. In one, Atlas looked almost paneled, as if divided into surfaces of differing reflectivity. In another, the sunward jet appeared as a smooth, uniform blue column instead of a ragged spray. NASA neither fully endorsed nor firmly denied any of it, repeating only that data would be shared once validated. Weeks became months. Validation never came. For many scientists, the issue wasn't conspiracy but trust. Even if the confusion was genuine, if experts themselves didn't yet understand what they were seeing, the vacuum of information let wild theories breed. Atlas turned from a pure physics problem into a question about transparency. When data is withheld, meaning multiplies. When explanation is replaced by silence, imagination moves in. Yet behind all the noise, a quieter revelation emerged from the numbers. Isotopic ratios of oxygen and carbon in Atlas did not match anything formed in our solar system. Infrared spectra, cross-checked with ALMA, pointed to an origin in a star system at least 7 billion years old, older than Earth, older than our planets, older even than the current architecture of our sky. That would make Atlas not just a visitor but a fossil from a vanished dawn, a survivor of a lost system, carrying in its atoms a record from before our sun existed. Its toughness, its metallic skin, its persistent order might all trace back to that ancient birthplace. Reconstructed surface composition revealed a nickel-to-iron ratio several times higher than that of ordinary comets. Nickel, corrosion-resistant, excellent for alloys and turbines, dominated over fragile ice and silicate. Some proposed a natural but extreme origin. Perhaps Atlas was a fragment of a planetary core hurled into space when its parent world was destroyed. That could explain its durability, a shard of a planet's heart hardened under crushing pressure. But even that failed to fit perfectly. Its reflectivity, magnetic behavior, and heat retention looked less like messy geology and more like a tailored mixture. In papers, this became non-standard metallic enrichment. In private conversations, it was simply impossible. A few dared to suggest a more unsettling scenario. Atlas as debris, not device, a remnant of technology rather than a functioning machine. A piece of something larger, once purposeful, now reduced to drifting wreckage mistaken for a comet. The evidence was circumstantial, compositional oddities, uncanny stability, architectural hints. No proof, only patterns and a stubborn sense that the object refused to behave like anything in our catalogs. Tracing its path backward, models pointed it toward a loose region of space not far from where the famous WOW signal was detected in 1977. Officially, the overlap was coincidence. Yet humans are poor at accepting coincidence when patterns start to rhyme. Even if Atlas is entirely natural, its existence carries a message. It shows that matter can outlive worlds, that memory can persist without mind. Imagine a fragment of a dead system still glinting under another sun, whispering across the void in narrow bands of radio and reflected light. It doesn't need to be a ship to mean something. Its meaning is continuity. As one astronomer wrote, maybe 3I Atlas isn't a messenger at all. Maybe it's a fossil, the trace of an attempt that survived its makers. In a universe that forgets almost everything, here drifts a small, silent remnant that remembers, its metals forged in another sunrise, its skin scorched by alien stars still shining in ours. Its history isn't written in words at all, but in isotopes. Maybe that's Atlas's real secret, not that it conceals technology, but that it behaves like technology, something built jointly by physics in deep time. As it slips past Mars into the dim outer cold, it offers no clear message, only the quiet endurance of matter older than Earth and older than our sun. In a universe this violent, simple survival starts to look like intent. The first link to the WOW signal began as the sort of coincidence scientists are trained to ignore. When Atlas's incoming path was traced backward and compared to old radio logs, its interstellar corridor passed close, within about 9 degrees, to the region of sky where the famous 1977 burst was recorded. That signal, a sharp spike at 1420 MHz, sat right on the neutral hydrogen line, long suspected as a natural calling channel for any civilization trying to be noticed. Decades later, Atlas produced brief radio whispers near 1.665 and 1.667 GHz, the hydroxyl lines. Hydrogen and hydroxyl, the two spectral ends of the water molecule. Two anomalies half a century apart, both short-lived, both never repeated, both sitting in the same family of life-linked frequencies. Avi Loeb ran the odds of that alignment in direction and spectrum happening by chance. The number, about 1 in 10,000, didn't prove anything, but it justified taking the connection seriously. Reanalysis of the original WOW data even revealed faint side structure hinting at hydroxyl offsets, like an echo around the main hydrogen note. From there, interpretations split. One camp suggested a resonant coincidence. Perhaps a dense interstellar cloud once amplified both hydrogen and hydroxyl lines, and Atlas, passing through long ago, inherited its unusual chemistry there. In that view, the comet is not a transmitter, just a physical keepsake from the same patch of space that produced the old radio burst. Others preferred metaphor. If the WOW signal was a fleeting hello, maybe Atlas is the footprint, a physical remnant from the same cosmic neighborhood or even the same culture now reduced to silence and inert motion. No one could prove any of it, but the pairing of hydrogen's voice and Atlas's glow was hard to dismiss as mere chance. Loeb quietly concluded that, symbolic or physical, the similarity demands humility. Two events, separated by half a century, might be aspects of one phenomenon we don't yet have words for. The universe rarely repeats itself. When it does, it might be tracing a pattern we're only just learning to see. By the time its orbit was fully nailed down, Atlas itself was dimming, a cooling ember drifting back toward interstellar night. Yet across labs and observatories, one consensus formed: 3I Atlas simply does not fit our neat boxes. It behaves like neither ordinary comet, nor asteroid, nor any familiar shard of debris. It is a reminder that the cosmos is built as much out of exceptions as rules. We like to think our equations cover everything: how light scatters, how ice sublimates, how gravity bends paths. Then something arrives from the dark and refuses to cooperate. Atlas offered a structure that seemed to breathe without a normal coma, an acceleration without obvious thrust, a brief radio murmur that never came back, a color shift our chemistry struggles to model. Each puzzle may eventually find a natural explanation, or expose blind spots we didn't know we had. The object forced astronomers into an uncomfortable balance. Skepticism and imagination, it turned out, were not enemies but partners. Real discipline means holding a mystery up to the light without turning it instantly into either miracle or hoax, letting speculation explore, while evidence remains in charge. Our calculations can pin its trajectory almost perfectly and still miss the meaning of what just passed us. Asked to summarize Atlas, Loeb put it bluntly: either it's a new category of natural object or it's the remains of something once constructed. In both cases, our picture of the universe has to stretch. If it's natural, then nature can imitate purpose with astonishing precision. If it's not, then intention can endure long enough to blend into geology. At that point, the line between made and grown starts to dissolve. Every major shift in science began this way, not with certainty, but with a stubborn anomaly, a wandering point of light that refused to match the model. Perhaps Atlas is one of those turning points, a quiet signpost toward physics we haven't written down yet. Its real lesson isn't to jump straight to aliens or miracles, but to take the unknown seriously. Let the data speak before our assumptions rush in to explain it away. That's why openness matters. In a universe that refuses to fit our theories, transparency and shared data aren't luxuries, they're survival tools. When information is delayed or blurred, stories rush in to fill the gap. Mystery turns into myth, and myth is hard to undo. So maybe Atlas's legacy has less to do with what it was and more with what it showed us about ourselves, our hunger for control, our fear of being wrong, our fragile balance between wonder and rigor. If the cosmos could give advice, it might be simple: don't define too quickly. Watch longer, listen better, doubt with kindness. Maybe Atlas was only a comet made strange by timing and angle. Maybe it was a fragment of intention, a scrap of an ancient attempt, or just a fossil of an environment long gone. Whatever the truth, it passed through our sky, burned briefly in our instruments, and then slipped away, quietly stretching our sense of what might wander between the stars. And as it goes, it leaves behind a gentle rule for anyone who looks into the dark. Stay curious, stay honest, and remember that silence is not the same as emptiness.